Hey guys, today we're going to be looking at parallel lines, and we're going to be using some of the special angle relationships that we talked about in 3.1 and looking at some theorems that go along with each one of those. So today our focus is parallel lines, and we have 4 theorems that we're going to start off with. Our first theorem, we have the corresponding angles postulate. And what this says is if we have a transversal that intersects 2 parallel lines, then corresponding angles are congruent. So before, without the parallel lines, we just had the corresponding angles a relationship. But now with parallel lines, we can say that those are congruent. The alternate interior angles theorem. If a transversal intersects 2 parallel lines, then our alternate interior angles, they are also congruent. And this is true for the alternate exterior angles theorem as well. They are congruent. And then our final theorem is the same side interior angles theorem, which is also known as consecutive. And this is the one that is a little bit different. Here, if we have a transversal that intersects 2 parallel lines, then same side or consecutive, however you like to word that, interior angles, they are going to be supplementary. It's one of our terms from chapter 1, meaning that the sum of those 2 angles is equal to 180 degrees. So those are the 4 postulates and theorems that we're going to be looking at today. And just a little bit about the difference between lesson 3.1 and today's lesson. In our previous lesson, corresponding angles, for example, which are 1 and 5, they are now going to be listed as angle 1 is congruent to angle 5. So the difference is being in the little symbol that we're going to be using here and here. Alternate interior angles. Let's say we have 4 and 6. Those are now going to be angle 4 is congruent to angle 6. Alternate exterior, for example, 2 and 8. According to our theorem, those are now congruent. And finally, with consecutive interior, we will use 3 and 6. These are the oddities, consecutive interior angles. They are supplementary. So angle 3 plus angle 6 is equal to 180 degrees. So this is what we will be using to solve some of our examples today. So in our first example, you can see we have our parallel lines, which that is indicated by this extra set of arrows here. Sometimes you may see 1, you may see that extra set of arrows indicates parallel. And there are three phases to these problems. The first thing we want to do is name the relationship. Second, we're going to set this up according to our theorems and find x. And then we're going to substitute that x back in to find the bold angle. Okay. So for example 1, we're going to name the relationship here, which we have two angles. They're on the same side and in the same position. So here we're working with corresponding. And we know that corresponding angles, they are going to be congruent according to our theorem on the previous slide. So now we're going to set those two angles equal to each other. We will have 9x plus 14 equal to 11x minus 4. And from there, we'll use our Math 1 techniques to solve and we end up with 18 is equal to 2x. We'll divide both sides by 2. And we get 9 equals x, or we can turn that around. X equals 9. So that's the second part of our example here. Now we're going to plug this back in. And our bold angle, it's kind of tough to tell here, but this is the 11x minus 4. So now we're going to substitute the 9 in for our x, and we will end up getting 95 degrees for our bold angle there. So the three parts that we're looking for: identifying the relationship, solving for our x, and then substituting that value back in to find the measure of the angle. All right, moving on to example 2. We're going to identify the relationship here, which we have alternating angles. They're alternating across the transversal, and they're both interior. So here we are working with alternate interior angles. And from our theorems, we know that these are congruent. So now we're able to set the two angles equal to each other. 7x is equal to 6x plus 10. And we're able to subtract our 6x over. And we get x equals 10, a quick one-step problem there. And our bold angle this time would be the 7x. And actually, we could plug it into either one because they should be congruent. That's a good way to check our work here. We have 7 times 10, which is 70 degrees for our bold angle. So we have answered all three parts: the relationship, found the x, and our bold angle. Okay. All right, I would like you guys to look at examples 3 and 4, copy these down, and I want you to start out by naming the relationship. You can pause the video at this time. All right, so the relationship for each of these angles, 3 is going to be a pair of alternate exterior angles. In example 4, we have consecutive interior angles. What I would like you to do now is set up each of these examples using our theorem from the first slide. You can pause the video now. All right, so you have set both of these up and solved for x. For number 3, we get x is equal to 9 after we set the two expressions equal to each other. For number 4, we get x is equal to 3. And here, remember, we're working with supplementary. So make sure that you add the two angles. Take that sum and set it equal to 180 degrees. For our final step, I'd like for you to take those x values, substitute those back in to our bold equations. You can pause the video now. All right. So after our first two steps in example 3, we substitute our 9 back in, and we get 110 to find our bold angle there, 110 degrees. For number 4, we substituted our 3 back into the equation, and we ended up with 100 degrees to represent that bold angle. So here's an example of each relationship that we're going to be working with: corresponding, alternate interior, alternate exterior, and consecutive interior, along with their corresponding theorems that we'll be using throughout this section. Also, I want to make a note that we will be using the converse of these postulates and theorems in our next section. And the converse, we are reversing the order of our statements. So here we use this to prove. This is used to prove parallel lines. So we will start out with the converse of the corresponding angles postulate. That says, if corresponding angles are congruent, then lines are parallel. So we have those same properties showing up here with corresponding angles are congruent, but now we're proving that the lines are parallel. Alternate interior, if those are congruent, then our lines are parallel. Alternate exterior, if those are congruent, then our lines are parallel. And then the one oddity, if same side interior angles are supplementary, then our lines are parallel. Okay. I'd like for you guys to take a look at the practice. And if you have any questions, please get in touch with me and then work on your homework check through quizzes.